Looking for experienced divers that have some training in the biological fields, and the ERT dive team really suited that need. We had a mesh bag that could be set over the unit, and then as it was lifted up, there was a drawstring on the bottom that could be pulled shut, and in this way we could encase the entire habitat inside a very fine mesh bag, hopefully trapping all of the fish, crabs, and other marine life that was on the habitat inside the mesh bag so we could bring it on board and take it back to the laboratory for analysis.
Inside the structures, items were loaded onto the line in trays and then manually rolled down the conveyor. After passing through an opening in the water wall, which was again utilized for shielding, items reached the survey and segregation area outside.
There's a monitoring station there with 2 gamma scintillators there. It comes through. If it gets a reading that's more than background, then it goes into the radium-containing materials waste stream, which means it's placed onto a second conveyor, and it conveyors down and it's dumped into a drum. If it doesn't get an inflection or anything above background, then we assume that it's surface contaminated.
Plants are vital, essential to all life on Earth. They process our air, water, and soil. They provide food and medicine. Plants have adapted to survive in some of the Earth's harshest environments, evolving into over 380,000 different species. This unique ability to adapt and survive is now being put to work by environmental remediation researchers. The science of phytoremediation, of using plants to control contamination, holds great promise as an effective and inexpensive means of cleaning up hazardous waste sites. Although still developmental, the clean green holds great potential.
Industrial waste containing PCBs was discharged into the harbor for over 30 years. Now it's estimated that a large part of the harbor, which is home to the largest dollar value fishing fleet in the U.S., needs to be cleaned up. For the cleanup of the relatively small area around the bulkhead construction, the hybrid dredge utilized a sealed clamshell to excavate the contaminated sediments, then deposit them into an onboard sediment hopper, leading to a positive displacement pump, which pumped the sediment water mixture through piping for onshore disposal. The hybrid dredge's clamshell is driven slowly into the contaminated sediment, closed and sealed. The telescoping boom then brings the sediment plug to the surface and deposits it in the onboard sediment hopper. From the hopper, the sediment is fed through a positive displacement pump, which transports the sediment through a plastic line for onshore treatment, transportation, or disposal.
In situ thermal methods, on the other hand, can be cost-effective, less disruptive, and don't pose the threat of releasing contaminants during excavation. Another advantage is that the degree of in situ process control can be achieved by measuring and monitoring the temperature rise in the subsurface. This program will focus on 3 types of in situ thermal technologies that have been proven in a variety of real-world applications. They are steam injection, electrical resistance heating, and thermal conduction. All 3 methods work by heating contaminants, soils, sediments, and groundwater to mobilize the pollutants. The heat can volatilize or evaporate the contaminants while reducing their viscosity, pushing them toward underground extraction wells, where they are pumped to the surface as a gas and/or liquid.
Soil washing is a natural fit for the geology at Vineland, where sand makes up the largest percentage of the soil matrix. The sand's medium grain size makes it possible to remove smaller and larger particles through physical screening. The sand is then processed through a series of chemical leaching and washing steps, which effectively removes and separates the arsenic contamination.
The first process is the excavation. The soil is excavated in the contaminated area. It's brought up to the blending pad, where it goes through the first stage of separation, which is a set of rotating screens that filter out the larger particles like the rocks, the sticks, and what have you, down to 1.5 inches in diameter.
At much higher radiation exposures than would be expected at a Superfund site, harmful effects can be produced in a relatively short time period, such as the radiation sickness seen in atomic bomb survivors. At Superfund sites, we are usually concerned with much lower exposures. Effects we are concerned with in this case are the radionuclides' potential to cause cancer. All radionuclides can cause cancer. Uranium is the only radionuclide where we also worry about the non-cancer effects when we clean up Superfund sites. Like most other cancer-causing agents, radiation is assumed to be harmful even in low doses. The risk of cancer from radiation increases as the exposure increases. To find out about radionuclides' toxicity, we refer to research done on Hiroshima and Nagasaki atomic bomb survivors, medical maladministrations, and uranium miners.
Each capable of generating 1.8 million BTUs of infrared heat. The screened bottom allows the heat to penetrate the bottom layers of soil. A vacuum then draws air upward through the tray at 3,000 cubic feet per minute, increasing the temperature of the entire treatment bed while volatilizing the contaminants. Using the vacuum has the advantage of lowering the boiling point at which the contaminants become vaporized.